Well, thanks for coming to this session. It's going to be about performance in SharePoint 2003 and capacity management. My name is Gökhan Uluderya. I'm a program manager with the SharePoint Performance and Scale team.
And I'm Kfir Amiad. I'm the performance test lead for the engineering team in SharePoint.
Yeah, well, it's okay. All right.
Okay, I think I can speak now. Okay, and I'm Kfir Amiad. I'm the performance test lead for the engineering team in SharePoint.
All right. So today, we're going to spend a fair amount of time talking about performance improvements in SharePoint 2013. We're going to look into some performance and scale benchmark results, so a lot of numbers and pretty graphs. And then we're going to use all that data and insight to actually reason about building our topologies and do some capacity management exercise. If this remote device works, could you please work?
And while Gökhan is trying to figure out the PowerPoint thingy, we do not have a network. We were hoping to demo some stuff. We have screenshots for some of it, and we'll talk about some other stuff, but we're really sorry.
All right, so let me start by saying SharePoint 2013 is engineered for better performance from the ground up. It really was a key focus area, a key investment area, starting from day one of this release cycle. When we started the release, we knew we were going to have a lot of new capabilities in SharePoint Server. We were going to provide our users and customers a much better experience, a much richer experience with a world-class, elegant user interface. And as a result, our servers would have more work to do, naturally. Our clients and our browsers would have more work to do. And we also had a global online service that was globally deployed, serving hundreds of millions of users. With that challenge, our goal was still yet very ambitious. We still wanted to make our product faster, more reliable, more scalable, and cheaper to run. And I think that's exactly what we did. We improved on all those four goals. Now, SharePoint 2013 server responds to incoming requests 50% faster. It is 50% faster when it comes to server response time. Your profile sync just got 4 times faster with SharePoint 2013. And if you choose to use the Active Directory-based import, you can get speeds up to 10 times what you have today. We're utilizing the available bandwidth between the server and the clients, the browser, almost 40% more efficiently. And we are doing 80% less SQL IOPS related to file I/O operations. That is huge, and I'm going to explain you how. And yet, the server is scalable, more scalable than ever, and you can have much bigger farms than you ever had. And one might think, well, these numbers might be coming from an idealized lab environment that may not apply to me, etc. Well, the fact is, on the contrary, we have been able to measure and validate all these improvements in our own live environments at Microsoft. These are numbers that we have quantified in our own live farms, some of the busiest farms that we know of. When it comes to performance, the most important thing at the end of the day is what your users see, what they get in their browsers. It's really not what you have in the data centers. It's not the kind of server that you use or the connection you have or what's happening on your network. The real judge is the end user. Now, keeping that key principle in mind, SharePoint 2013 brings down the content that your users care about the most, the first. So we have this new technology that we call active download management. Actually, one of the inventors and implementers is sitting right in the front row here. Thank you. Allows us to prioritize resources and JavaScripts that bring down the content foremost and top. So we're going to show you about the improvements in a later slide. SharePoint 2013 has a much better browser experience. It has smooth transitions. I'm sure you have seen it. You've used it already with SharePoint Online. It has smooth transitions with animations and better download strategy, where we basically download and render only the changing parts of the page, only the deltas, as you navigate within SharePoint. And on top of that, you have a much better, richer, and more interactive browser experience. Based on your feedback, we have made significant amount of engineering investment into making SharePoint wide area network optimized. We have a global service to run. A lot of our big customers are geo-distributed, so this has been a key factor in our decisions in this release. The server has been extensively tested under wide area network conditions with latencies up to 300 milliseconds, much higher than what you would have from here to Asia. The latency from here to Chicago or Boston is about 50 to 75 milliseconds, the round-trip latency. And the server uses the bandwidth much more effectively. We talked about that, up to 40%. It's amazing results. And we use the IES compression and image compression techniques much more effectively on the server side. The server is faster than ever. It responds to the HTTP requests much faster. And it does much better use of the communication ports that are open between the client and the server. The ports between the browser and the client ramp up a lot faster, and I'll show you some of them in a second in some real network traces, thanks to low-level TCP IP level optimizations we have done. We've gone that deep on the stack to optimize SharePoint. And the last, but not the least, we're actually leveraging content delivery networks for serving JavaScripts in SharePoint Online. Now, it's a technology we love, and we'll invest more into it and try to make it available more widely. Now, with all that, with all those changes and optimization, let's see the impact of these changes on one of the most popular pages in SharePoint, clearly, Team Site. You are seeing a visual representation of the network trace for Team Site under 300 millisecond latency, round-trip latency, and with 1 megabit per second connection between the server and the client. 1 megabit per second is actually a bandwidth that is even lower than what you get on your cell phones today. But some of our customers actually have that kind of a connection. And 300 milliseconds, as I said, it's much higher than the latency that you have from here all the way to Singapore and back. So what you're seeing on the graph is that SharePoint 2013 server is making a much better use of the communication ports available. The swim lanes are the ports that are open, and the rectangles, the colorful rectangles, are your content that's traveling over the wire. Your images, your JavaScript, your HTML. You see no idle time with SharePoint 2003 on those communication ports. They are busy doing something useful all the time. And you see the white patches in the 2000 trace where those communication ports, the same ports, were idle and waiting other things to happen. So with all the technologies that I described, with the minimal download strategy, with active download management, with script on demand, we have been able to fill this pipe almost 100%. As a result of that, you are seeing that 40% improvement in bandwidth utilization. Look at the graph for SharePoint 2010 and look at what SharePoint 2013 is doing. The blue graph is what's happening on your network from a bandwidth utilization point of view. We download 65% less bytes for images, thanks to better use of image compression. We download 20% more bytes for your JavaScript, which directly translates into more functionality and better functionality in your browser. And in total, 15% less bytes for this specific scenario with this specific benchmark. And most importantly, the content that you care about on this page, the document library, the Chrome, the navigational elements, the carousel in SharePoint 2013, is coming down a full second faster compared to SharePoint 2010. Well, clearly there would be no better person to speak about the product than the product itself. So we're going to try to show you the experience with SharePoint 2013, but I'm not sure where we are.
Well, actually, I think you'll need to just look at me talking, unfortunately, because we do not have network. However, I will say this. We were going to demo a few key scenarios for you interacting with SharePoint, with team sites, with my sites, going to and rendering Office documents in the browser. And we were going to do this on SharePoint Online. Now, if you paid close attention yesterday at the keynote, Jeff Tepper mentioned at the end of his demo that actually the entire demo was going off of our farm in Amsterdam, Europe. We were actually going to see here how the experience is almost as great going to the data center that we have over in Singapore, Asia, where, for example, you can see that we can render a 30 meg Word document in 2 seconds from here, where we have about 200 millisecond latencies. We don't have network. If you want to go and try it out, you can go and create a trial tenant over. But unfortunately, I'll have to pass it back to you, Gökhan.
Right. And we were hoping that we would also show you the experience with the transitions and animations that unfortunately we can't. So we will let the product speak for itself later as you actually create a tenant in SharePoint Online. Well, we have 2 related sessions to just the topics that we talked about right now. If you'd like to learn more about making pages faster in SharePoint and how we did that, you can actually go to Sterling's session tomorrow evening, where he will talk a lot more in-depth about minimal download strategy, active download management, and script on demand. And actually, he'll explain to you how you could leverage those technologies as you're customizing your SharePoint. And we have another session this evening. A lady was just walking around distributing posters. She's going to present a session about optimizing SharePoint for wide area networks. So that session is going to happen tonight. I'm sure it will be very useful. Well, we're not done. That's not all. SharePoint farms can now scale more than ever. Your farms can become much bigger. We have improved some of the key limits in the product that will help you grow, that will help your business grow as your SharePoint grows. Now, you can have up to 750,000 sites in a single farm, tripled compared to SharePoint 2010, where our limit was 250,000 sites. You can have 10,000 sites per content database, up from 5,000, doubled. You can have 500 of those content databases in your farm, as opposed to 300. Now, I would like to remind everybody that the limits apply to each dimension independently. So you cannot really take the number of content databases, multiply it with the number of sites, and say I can have 5 million sites all of a sudden. You run into different bottlenecks in the system. So you need to consider each dimension independently when you're designing your farms. Keep the equalizer metaphor in mind. You just cannot maximize all of them at the same time. We've got a much more efficient file I/O pipeline and a storage layer. In SharePoint 2013, the writes to the database are proportional to the size of the writes, size of the updates, as opposed to the size of the file that you're changing. That did not used to be the case before. Now, considering most of your operations are updates to existing content, you can easily see what kind of a difference this can make. In our own internal SharePoint deployment, we have seen up to 80% reduction in SQL IOPS that are related to file I/O operations. 80%. That's an amazing number. Now, we're also leveraging some advanced features in the SQL database that allows us to reduce the number of full table scans dramatically and also have much wider lists spanning multiple rows in a table. Now, all these combined translate into a much more efficient and much more scalable file I/O pipeline and a SQL database layer. And you'll see the results, the impact of that in some of the benchmark results that we're going to show you. We are a lot more reliable. The server is a lot more reliable. It works when you need it to work. And it's much more scalable, thanks to a few key features that we have implemented in this release. Distributed cache is a centralized, scalable cache that powers the social experience in SharePoint. And it helps the SQL layer and the front-end layer because they have less to do thanks to this cache. Search has a brand new fault tolerance and scale model. You can scale indexing, querying, and crawling independently. Search also has a new deployment model that is primarily based on virtual machines as opposed to physical machines as it used to be. So it's much more flexible. Request Manager is a feature that we are proud of because both Kafir and I worked on it. Is a feature that allows you to do software-based, intelligent, and SharePoint-aware, most importantly, SharePoint-aware routing and load balancing. It actually will help improve reliability of your farms and improve your user experience. Now, Kafir, if we could do that, is going to show you how you can leverage Request Manager for that purpose.
So again, apologies. We were planning to have a live demo. However, given that we have no network, I was actually lucky enough to get 15 minutes this morning where I did have network connectivity, and I took some screenshots. So you'll have to take my word for that again. The setting that we had for the demo is a simple small farm with 2 front ends and 1 request manager in front of them. Now we also have a Visual Studio load test that was sending requests to this farm through Request Manager, just a simple homepage request. And I'm going to take you through a few situations, a few scenarios where Request Manager is helping improve performance and availability. The first scenario that we're going to talk about is health-based routing. Most of you probably remember that in 2010, we introduced the health score feature, where SharePoint is actually looking internally at its health of the front end. And as the machine gets busier and slower, it sends a higher health score, such that 0 is very healthy and 8 or 9 is pretty unhealthy. Now, in 2010, some client applications like OneNote or Outlook took this health score and helped improve the reliability of the server by sending less and less requests as the server is unhealthy. Now, in 2013, with Request Manager, we took it to the next level. In 2013, Request Manager is monitoring every response that comes from the server and looks for machines that become unhealthy. And as the machine becomes less and less healthy, it sends less and less traffic to it. So it sends less and less traffic to it. So what do you see on these ugly-looking screenshots? And again, apologies. Down here, you can see that we have a pretty healthy farm with requests evenly balanced between the two front ends. The yellow line up here is the Request Manager request per second, and down here, you see every front end. And as I simulated an unhealthy machine by setting the health score of one of the machines to 8, you would see that Request Manager is sending less requests to the blue machine and more requests to the purple machine. Now, there's a few advantages to this. The first one is that usually as a machine gets unhealthy, it means that resources are heavily being utilized. And there's a direct correlation between high CPU or low memory to high latency for requests from the user. So users will not experience this high latency. The other benefit that it has is that it gives the machine a chance to recover automatically by reducing the load on it, finish processing whatever heavy request it was processing, and as it is done and becomes more healthy, Request Manager would automatically even out the load again and adjust the load such that all the machines get the same requests. So health-based routing is one way where Request Manager is helping you. The next scenario that we're going to talk about is when the server becomes really unhealthy. In SharePoint 2010, if you remembered, we introduced the server busy concept, where if the server was really, really kind of falling over, we prefer to just not have the user wait in front of a blank screen for 30 seconds before they see something, because that's kind of annoying. And so we fail immediately and send this server busy message. The HTTP error code is 503. And with Request Manager, all of this is going to be saved from the user now, because Request Manager is continuously monitoring every front end. It sends a ping to the front end every second. And in a few seconds, it can detect that the machine got into this really server-busy bad state and automatically remove those requests. So let's see at how it looks. So if I had the internet, you would see that browsing to that unhealthy machine, you would get this ugly error message saying try later. Nobody likes that. And when RM actually removes the machine of rotation, the user actually still sees the homepage as they expect. And what you can see on the screenshot here is that you'd see far less requests being sent to the blue machine. In fact, no user requests are being sent to the blue machine. These are only the pings that Request Manager is sending, whereas all the traffic is routed to the healthy machine. And again, the healthy machine picks more requests. It continues to deliver great latency. And the users didn't really experience none of the server busy problem. And the third scenario that I wanted to talk about is a scenario where the machine is kind of not there at all. Sometimes we have hardware failures. We're running the service. We see some, sometimes VMs dies or physical machine dies. Or sometimes you as the IT admins, you do some maintenance, you do some patching, you run IS reset, which, by the way, I don't recommend anyone to run because things will not always come back after that. But anyway, the point is that sometimes the server is not even there. And again, Request Manager, so this is what you'll see, right? Service unavailable, kind of not a great user experience. And since Request Manager is monitoring the machine, it would, again, remove the machine off rotation. Users would be routed to all the other front ends while you get your SCOM alerts or whatever other indication, and you go and you fix it. So you don't need to be so worried anymore on going to do some patching on one machine, and I have to double check 50 times that I removed it from my hardware load balancer, et cetera, et cetera. Request manager would pretty much take care of it for you. Back to you.
All right, let's switch back to the desktop here.
We will take questions at the end, if you don't mind. We have a Q&A at the end.
Thank you. All right, so we have actually a dedicated session for Request Manager tomorrow evening that Spencer Harber is going to present. So you can get more details around how to configure Request Manager for your environment. So I think it's now time to dive into the wonderful world of numbers and graphs that show us the performance benchmark results for SharePoint 2013. So one of the top questions is always how SharePoint is doing against one of its top competitors. 2010 in this case was 2013. So I think there's a clear winner, and I'll explain why. We took the same benchmark, the same workload that we used to run against SharePoint 2010 to test performance and scalability of that server product, and ran it against SharePoint 2013. The test bed consisted of 4 front-end servers that were all VMs, by the way, not physical machines, because that's what most of our customers would like to run, and against a single SQL database, right? And what we get, and so by the way, we did the tests in 2 operating regions. One region being green zone, as you're seeing on the graph, where the front-end server resources are utilized at a moderate level, so we're not really stressing the system. And the second operating region was the zone that we call the max zone, where we basically did as much as we could on the front-end servers. Basically stress it out, take it up to 90+% CPU utilization to really see how fast you can drive the server. What you're seeing is 15% improvement in requests per second in SharePoint 2013 compared to SharePoint 2010. You're getting about 110 requests per second from a single virtual machine. That's a lot of RPS. And we are actually doing with this specific benchmark that has your collaboration mix. It's not just file I/O or any specific transaction. It's a mix. We're doing 15% less SQL IOPS. That's really the definition of doing a lot more with a lot less. And the best part of it is that the latencies, the server response time, has improved by almost 50% on the 99th percentile. 99th percentile almost covers all the requests that are coming to the server, the tail end of the performance that actually matters deeply. And 10% improvement on the 95th percentile. That is huge. And the question easily morphs into, so, well, I understand. You got the 2010 features, 2010 workload. You ran it against 2013, fine. What happens to the new server when I have all these new great features and capabilities? So we devised another benchmark that was a lot harder, a lot bigger than the benchmark that we just showed you, that had collaboration, social, metadata navigation, community sites, all that fun stuff in it. And we were able to get up to 60 RPS per front-end server. Again, virtual machines running against a single SQL server backend, by the way. I'd like to point that out. And what you're seeing in the graph is a healthy, scalable system where we were able to go up all the way to 10 front-end servers against a single SQL server without SQL Server even sweating. 10 to 40% CPU utilization, even in the max zone. Right? You see a bit of a tapering off towards the end. That's normal. You run into various bottlenecks, stretches in the system. But look at the latency lines. you get a very nice, smooth, consistent latency, both in the green zone and the max zone. That's your average latency. And the around 500 millisecond latency on the red zone is a lot better than what we had with the SharePoint 2010 server. So there's been a great amount of work to actually make this graph possible. Okay, so we looked at improvements, benchmark results, and I think we have enough data and insight to reason about capacity management. Well, capacity management is an iterative management process. You know, we confuse it with planning. It's not just planning. It's a live process. It's an iterative process where planning is just a step in it. If you look at the guidance that we had in SharePoint 2010 timeframe, we haven't really changed drastically what that guidance will be. So the idea at a high level, the concept at a high level is simple. You model, you start with a set of assumptions about your workload, or you have data from your existing SharePoint deployments. You use that data to come up with a design for your farm, and then you test your workload against that design that you came up with. And if it all works out, you operationalize it, you deploy it. But you're not done. It's a live system that you have created for yourself, so you have to monitor resource utilization, monitor usage on a continuous basis. And if you need to make a change, you react to it, you fine-tune the system. And you might go through this cycle several times until you get to a perfect state. Well, there is no perfect state, but let's assume you can get to a reasonable state. And the key is your needs change, your business changes, your users do different things, and your adoption changes. So you need to be able to react to these changes. As I said, it's a live system at the end of the day that grows as your business grows, right? So be expecting that change and being ready for it, you know, being able to fine-tune when you need it, understanding what's happening in your system is really the key to being successful with capacity management. One of the most important things is the farm design, is getting the right design for your farms, the right topology. It's really like taking your furniture and fitting it into a house. First, you need a big enough house, and you need a great floor plan. And then you need to know what each piece of furniture does, and make sure that they show up in the right room to really have a meaningful living experience in your home. SharePoint 2010 was really a milestone in terms of the proliferation of the service applications. The ecosystem just evolved to a different dimension, right? And our guidance at the time was more or less creating a separate application server deployment for each of the service application you had. Some of us did that. We built big houses with many rooms in it, and then we put each piece of furniture into those rooms, and it was a working approach, totally fine. And some of us basically said, you know what, I only have 3 rooms, I'm sorry. And I will just squeeze in everything in those 3 rooms, no matter what you tell me. That's what I have. So you see the problem with both ends of the spectrum, right? In one case, you ended up with a large house with many rooms, hard to manage and costly. And I bet you actually ended up with a suboptimal experience as well, because you ended up with a dining room that has a table in it but no chairs to sit on. And on the other hand, some of our customers ended up putting a washing machine next to their TV in the living room. And then you could not possibly be happy when the washing machine started working. Washing machine, let's say, crawl service. And you would not be a happy camper when you're watching Monday Night Football, when that thing actually kicks in. So we're going to introduce a new approach, a new framework to farm design. It's going to be primarily based on optimizing for end user experience, optimizing for reliability. It is different than the guidance in 2010. It's not contradictory, it's complementary. We think it's going to be more responsive, simpler to manage, and actually flexible. And I'll show you how. The idea is simple. You categorize your service applications based on their behavior and their characteristics. Now, some of our service applications serve end users directly. They are interactive. They are right up in our face all the time. They have to provide a very consistent behavior with very low response time. And some of our service applications, they do a lot of heavy lifting, background processing. They can get noisy and spiky. So the idea is basically separate them into their separate layers and manage them understanding this behavior. Yeah, and trivially, your database is always your data layer. You know how to deal with that. It's common. And I'll show you what the SharePoint floor plan looks like based on that layering approach. The routing and caching is now a layer where almost all SharePoint requests goes through. They are really on the critical path now for almost every request. So you want that layer to be super fast and provide very high throughput in a very consistent way. Your front end hosts your service applications that serve your end users directly. They don't need to be as fast as the caching and routing layer, but they still need to be fast and consistent. And your batch processing layer is where the heavy lifting happens. It's noisy, it's spiky, it might be slow. That's okay. It does not impact your end users. They are still happy. And you can actually have a higher resource utilization level at this layer, driving your servers hard. The database layer is always the heaviest and the most responsive layer because almost every request ends up there. So we've got a few exceptions to the rule, but I'm really happy to say they are just a few. Search being one of them, based on what it does and how it does it, architectural and behavioral. And you have the BI stack, Excel, Performance Point, that might have components that span both front end and batch processing layer, or they have interesting pattern when they are under heavy use. They use a lot of resources, memory or CPU. Now, these specialized workloads can actually be hosted on the front end just fine. You need to think about them separately, except for search. You need to think about them separately only under heavy usage. You are a project management company and you have project, then you should think about separating project onto its own application servers. Or you're heavy on BI, then that's when you do it. The beautiful thing about this floor plan is that you can actually manage each layer independently. You can scale up and out independently. The layers are homogeneous. The resource utilization on the servers that sit in this layer are utilized the same way. When you run into a problem from a capacity management point of view, you just add one more of them. You don't need to think about each service application separately. You don't have to specialize on how you monitor or manage them. You just add more resources to each layer. Another thing is, this approach really lowers the barrier to high availability. When you have 10 service applications and you try to deploy them all on their separate application servers, and if you want to make them fault tolerant, well, you would have to replicate every server. 2 minimum for each service application. Now with this, you can have HA with just 2 front-end servers that has all your services running. Again, it all depends on how you're using the system. But this does lower that barrier for entry. Now let's look at how your topology evolves based on this approach. You have less than 100 users? Well, you're really living that studio apartment lifestyle. You hardly come home. And you have a very simple workload, an interesting lifestyle, but you want to get out of it as soon as you can. As you get more serious, you start thinking about your front-end layer and database layer separately, because fault tolerance starts mattering for you. Your data starts mattering for you, and you've got a lot more users. And just see the progression in each layer as you grow and grow, right? As you get thousands of users, then your batch processing starts mattering a little bit. So you might want to introduce that batch processing layer so that you offload that spiky, heavy lifting load into its own servers. And search, you might want to think about it differently and separately. Search is really your transportation vehicle that lets you get to places, but the moment you promote yourself from a bicycle to a motorcycle or a car, you just can't have it in your living room. It's really how it works. So you're going to have to probably split that earlier than other service applications. And as you grow more and more, you add servers at each layer. You increase the resources at each layer. Your topology is now going to be big enough to consider routing and caching as a separate layer, right? And based on the number of users that you have, the kind of workloads that you have, you might now have a few specialized workloads that you're going to think about separately. But again, that I'm hoping is going to be an exception for most deployments, not a common pattern. All right, thank you. Now, this is a breakdown of our service applications based on their characteristics. Trivially, request management, distributed cache, they end up in the routing layer. Services like Access, Excel, managed metadata, user profile access services, they sit on your front-end server. And the things that do the heavy lifting, like crawl, work management application, that it actually goes off and hits multiple sites to gather your tasks in one place in the background. They are a great fit for the batch processing layer. The ones that I have in red are those exceptional workloads that you might have. Search, an exception on its own. There's a session that I would like you to go to understand how search can be managed and deployed and scaled out. But Excel, Performance Point, our service applications, as I said, you could have them on the front end until you're making heavy use of them. Now, there's a session about designing your SharePoint server for enterprise deployments that happened yesterday. So you can get more details about various design patterns and topology patterns by watching the recording of that session. And there's a separate session about search deployment and capacity planning that you might want to go to get more details about search. So I think now everybody's thinking, so tell me how many servers I need on each layer. What does my SharePoint look like? And the answer, the truth, is actually it all depends. Your SharePoint is unique because there are so many dimensions that define your SharePoint, and it's different than mine. Your workload matters, the number of users, where those users are, what those users do, what kind of a load they generate. The hardware that you buy, the network infrastructure that you have, the way users connect to your deployment, your topology matters. Your data set could be small or large. You could be doing real-time collaboration, archiving. You might have data in one place or distributed across the globe. And everybody has different SLA requirements. Our service needs to be up and running all the time, even when disasters happen. Some of you have deployments where you're okay with a Thursday night maintenance window. All these things combined really define what your SharePoint looks like, how big or small your farms are, what kind of an architecture you're going to go and implement. So let me turn to Kafir and ask him to explain to us how our SharePoint looks like within Microsoft.
Yes, so we looked earlier at some lab benchmark results, and those are nice, and you see the nice kind of charts going up as we add more machines. But what's more powerful than actually looking at the real-world server? And we on the SharePoint team, we actually run our own servers. This is actually a key part of our engineering process. It helps us learn a great deal about the manageability issues that you guys might face later and fix them. It helps us learn about performance, about reliability, such that we can continue improving the product before we give it to you. Now, for the Office organization, we have what I think we define as a medium server. We have about 15,000 users in total, where about 9,000 of them are using the server every week. And we see about 2,500 unique users every hour. The workload that we have on this server are pretty much across the board, from collaboration, social, we do document management and taxonomy and doc sets, et cetera. And we also do project and search. So pretty much all of SharePoint. We have about 1.3 terabytes worth of data across over 1 million documents. And they're all spread across 10 content databases. Now, those who read the slides quickly would see that we have the largest site collection that we have is almost 300 gigabytes. And those who already saw the boundary documentation that we published last week might remember that our limit is 200 gigabytes. Now, going back to the plane metaphor we used earlier, when the Boeing company is creating a new plane, well, they stress the wings and other parts of the plane really hard, such that when we fly in it, it's very safe. And we kind of do the same. We want to see how things go slightly beyond the limit to make sure that things are working great for you at the limit. Well, now let's get to the most interesting part, the how much hardware we use. So for the caching and routing layer, we use 2 machines. Actually, we also use VMs, Hyper-V, with 4 cores and 14 gigabytes of RAM. The reason why we use 2 VMs for this layer is not because it's resource heavy. We actually see about 10-15% resource utilization over about 50 requests per second. And memory utilization is not high, but we want to have the high availability. And the gentleman that asked earlier about do we need a load balancer or not, well, the answer is, in this case, you do need a load balancer to send requests evenly to the 2 request manager machines we have. Now, we support all of this load with 3 front ends that run, as you'd expect, around 50% CPU utilization during peak times. This allows us more room for growth at extreme events. Sometimes, Jeff Deeper or whoever would send an email, go click on this link and see some really important information. And so we want to leave some room for spikes. And we run at about 10 to 11 gigabytes of RAM. In our batch processing layer, we have 4 VMs. They're running pretty heavily utilized. We have things like the search crawl requests. When you need to crawl 1 million documents, you have to do a lot of requests. We have heavy lifting timer jobs that also run in there. And so these machines are actually running pretty hot on resources. They're running at around 80% CPU utilization, about 12 gigabytes of RAM on each one of them. But that's perfectly fine, because no user request ever ends up on these machines. And so we actually feel like we can get the most out of the hardware, drive it all the way to 80%, such that we fully utilize it. And then we have 3 databases. We actually run SQL on physical machines. We use 8 core machines with 64 gigs of RAM. And we actually don't use a lot of CPU on them. We do use all the RAM eventually because SQL is caching stuff in memory. We actually, one of those SQL databases, we fully dedicate to the logging DB. This is the database that have all sorts of information about requests. You can have perf counter in there, et cetera. And we do heavy telemetry on our servers to understand every aspect of it. But in reality, you would probably need 2 databases to support this kind of data and to have the high availability that you'd expect out of SQL. Now, in terms of SLAs, we run the server at 3 nines availability. We actually, when we monitored the SharePoint Online service, we actually run at 4 nines. The big difference here is that the engineering team is upgrading and patching every week, sometimes even sooner. And so as you mess up with your servers, I'm sure you all did patching or whatever maintenance on your servers, you know that this would impact availability. But still, 3 nines for upgrading every week is pretty darn good, we think. And then finally, the latency, again, during peak hours, the 99th percentile latency is around 500 milliseconds. And what 99th percentile really means is that 99 out of the 100 requests are served fast. And you might have seen this in the past, where most of the time the server kind of looks healthy and responsive, but sometimes you don't know what it's doing, right? And so we're tracking the 99th percentile as a metric that helps us make sure that this sometimes it's slow is not as frequent. And we talked about making 50% improvement there.
Right. So, well, this is a question that we get pretty often. Is there a magic calculator that just gives me the answer that I need when it comes to capacity management? Well, I'm probably going to surprise you by saying there most probably is one. But it's not about the existence of that calculator. It's actually about what it looks like and what you can use it for. I'll give you one simple example, distributed cache. The concept is simple. It just stores things. It requires memory and a bit of a CPU. Now, if I were to give you a calculator for distributed cache, this is what it would look like. And I'm not expecting you to read the list now or later. It would have about 40 parameters in it that you would have to understand, reason about, and provide values for. And not only that, you would actually have to understand the internal workings of the cache to actually understand some of these things. I think you would fail, and I think I would fail. Because first, you would not know what the values should be, so you would put in the wrong data to just get out the wrong data. Instead, we'll give you this, an oversimplified table that has taken the precision out of the equation. You're not going to be precise. But we think this is going to make us more successful. It's a rough estimate at the end of the day, but this does help you make that macro decision about how many servers I need and what do I need to use, given my own profile. You just need to decide which bucket you fall into. We will share some of the assumptions, at least the understandable assumptions behind this table with you, so that you can decide yourself whether those assumptions are reasonable or unreasonable for your own environment. But again, as I said, I think this table, simple, understandable, will serve you better. So when it comes to capacity planning and capacity management, cookie-cutter approach just does not work. As we talked about it before, your SharePoint is unique. And a specific benchmark or a technical case study that we publish is not going to be the answer to your problem. And we could publish millions of them. You would still have the 1,000,001st case where we would miss. So instead, I would like to do a little prescriptive about being successful with this process. As I said, the topology matters a lot. So having the right architecture is 90% of the problem. If you have the right design for your farm, and if you have the flexibility to change it or fine-tune it when you need, you have solved 90% of the problem. Try to allocate enough resources. Do not undersize. Because solving an undersizing problem is really a really complex and a costly problem to have. So if you can, allocate as much resources as your budget allows to your deployment. The key is understanding. The more you understand, the better you do. We need to understand the usage, our users better, and monitor utilization on our servers. And fine-tune as need. When you need to make a change, don't be afraid to do that. As I said, I think the topology recommendation that we're providing you is actually going to make it simpler for you and will hopefully facilitate changing more easily. To make you successful with this whole process, we're going to provide a lot of documentation and prescriptive guidance when it comes to topology so that you have the right design for your farms, and you will see a lot of data coming out of us for specific workloads that matter for you that shows the performance and scale characteristics of various workloads and the resource utilization levels under various conditions. SharePoint already has a lot of stuff built into it that allows you to understand usage and monitor the system. And we will support that with more guidance and documentation so that you can actually understand your users and your system better. Well, with that, if you have any issues or questions, SharePoint team is always here to help. Thank you very much for coming to the session. We will do some Q&A. There's an evaluation available on the website. We'll appreciate if you go and evaluate the session. Thank you again. Thanks.